Hello, everyone. Thanks for joining us for the Modern Applications Needs Modern Security webinar. Today we have a special guest, Brock Allen, joining us and delivering this webinar on our behalf. So thank you, Brock, for giving us some of your time, and thank you all for joining us today. Unfortunately, Peter Carson, as you all know, the president of Envision IT and Extranet User Manager, SharePoint MVP, he's unable to join the webinar today. He's currently on a plane trying to get to Montreal. We had a huge snowstorm overnight, which delayed his flight. So I'm just filling in him. My name is Dinesh Sohan, and I'm going to open up the floor for Brock to introduce himself and get this webinar started.
Great, thanks. My name is Brock Allen. I am, I guess I would call myself an application security architect. That's kind of security is a big field, but I focus on identity and access control. And basically, I do consulting and I help my customers design their identity systems and achieve things like single sign-on and web API security. And those topics very much involve these protocols that we're going to be talking about today. OpenID Connect and OAuth 2. When I'm not helping customers, I work on a couple of different projects. One of them is something called IdentityServer, which is definitely being used by Extranet User Manager. They're using it internally. It's a free open source framework for helping implement these security protocols. I also work on something called Policy Server. That's a commercial product that is around the authorization space. So IdentityServer very much helps with the authentication problem in your architecture, and Policy Server is designed to help with the authorization part of that. So today we're going to be focusing on the authentication piece of that. And what we're going to do is talk about a little history of authentication and authentication protocols, and kind of see where we came from and understand why we got to where we are. And we're going to then talk about where we are specifically with those two protocols I mentioned, OpenID Connect and OAuth 2. And we're going to go over actually a little bit in the technical detail level how those protocols work. Security is definitely a complex topic, and so we're going to work through some of the choices you have in choosing how to use those protocols, depending on the types of applications you're building. So when I started doing, programming way back when, which was well over 20 years ago, the security landscape was definitely different, and sort of the context and assumptions were very different. And we kind of had the concept of, your enterprise security, which is our triangle here in the middle. And then we had the notion of like customer-facing web applications, which is how we would expose whatever our company provides as features to our customers. And so authentication obviously is a big important piece of these things, but it was different depending on which of the two modes you were in. So for the enterprise style applications that you wanted to authenticate to, the idea is that a user would come into the building owned by the company, and then they would go into the office that was owned by the company and sit at the desk that was owned by the company, and go walk up to the computer that was owned by the company, and they would log in with their credentials that were owned by the company, right? And so the idea here is that you were going through this sort of perimeter to use your enterprise credentials to then log in. And typically we were using like Active Directory, and you would get logged into your Windows machine, and you would now be in the trust perimeter, if you will. And then you could go off and use your desktop applications that IT had built for you, or you could use the web applications that were like hosting at IIS, and those could do integrated Windows authentication, all against Active Directory, and basically doing kind of Kerberos under the covers. And that's how you did security, back then. And the fundamental, architecture there is all based on the premise of that you're in this trust boundary, that your computers are domain joined, your web servers are domain joined, and you're in that enterprise. For our customer-facing applications, those were a different breed of apps, right? Those basically ran in like a DMZ on a separate web server. They were probably not domain joined, or they may even be in like a colo that you would rent out. And those would do authentication in a totally different way, right? Those would do username, password. There would be a database for the passwords of your customers that were coming in. And again, they came in and used the customer-facing sort of applications and authenticated in a totally different, architecture. So that was kind of how we did things a long time ago. Over time, then, our requirements changed. We started getting requirements for both types of applications. One for your business applications. Very often your company would have a business partner. And this business partner would say, hey, I want my users that are over in my Active Directory to be able to use your applications. And so we had to evolve, right? And our industry evolved in the enterprise space and came up with enterprise grade authentication protocols to be able to support that sort of federation model. And yeah, Kerberos did support, and Active Directory supported, domain trusts. But at a higher level, for the application level things that we were building, we came up with these other protocols like SAML and WS Federation. Those were used for browser-based federation, and WS Trust and WS Security were more for like the desktop style applications. And those were all very XML heavy, back in the era when SOAP and all of those protocols kind of ruled the world. But that was very much within the enterprise still. A similar kind of move happened in the consumer space, the consumers using your web applications. They also wanted some sort of federation. And this is where things like Facebook and Google as identity providers were becoming, prevalent. And so your web application also sort of had to evolve and utilize social logins to get your consumers into the web application. But again, at a high level, the concept's similar, but the implementation and the details of how that's achieved are just totally different, different approaches. So especially in the social login space in the early days, they were just sort of each company like Facebook and Google were just sort of inventing their own way of doing things. And so you had to adhere to their custom proprietary approach to get that to work. Okay, but again, these are two totally separate styles of apps for the two totally different styles of users using the different applications. Okay, so this thing came along. Okay, and actually it's about 12 years ago. I looked it up. It's been about 12 years now since the iPhone has come out. And so the idea is that this thing totally revolutionized or forced us as developers and as security, professionals to up our game, if you will. The idea is that this device came out and basically we're targeting both sets of users. And now your corporate users, because they're consumers, they had one of these things and wanted to start using the iPhone to use the enterprise applications that they were using on a daily basis. Also, of course, consumers had this thing and wanted to be able to use apps on their iPhone to be able to connect and use the services that your company was providing. Okay, and so the thing about this is that when Apple and Steve Jobs came out with the iPhone, they basically thumbed their noses at the enterprise. They basically said, forget you guys. You guys are all your overly engineered, overly complicated, SOAP and SAML and domain join and all of that. Forget it. We're not even going to handle that. We're not going to support it. We don't care about you guys. And instead, what Steve Jobs got up on the stage and said is, we're going to support this thing called HTML5, and we're going to do these web API calls, and it's all going to be JSON based. And that's the basis for our platform. Okay, so I don't care what you enterprise guys have been doing. I don't care about it. I don't want to hear about it. This is what we do. Okay, and that's exactly what had to happen. Was we had to adapt to what this device forced us to do, basically, so that no one's going to tell the CEO coming in with their iPad that they can't see the monthly sales reports from their iPad, right? It just does. They're not going to understand that your iPad doesn't support SOAP. So that's why we had to change. Okay, so this is where our modern sort of picture comes from, and of course now the modern security protocols to enable this scenario. So here's a picture of kind of what some of the modern types of apps that we're building these days. We have server-side web applications that we're building. Those are your traditional server-rendered HTML. That might be like Java server pages or ASP.NET types of things, PHP, that kind of stuff. We have more and more applications that are running in the browser as well, like JavaScript SPA style applications using Angular, React, and things like that. Of course, then we have all these native apps that are running on your iPhone or your iPad. But these also could be your desktop applications that we used to build in the past for the enterprise. And all of these types of applications want to authenticate the user. They want to know who that user is. So that's the first thing we're going to want to figure out how to do is authentication. And then, of course, because web APIs are all the rage, and that's how we expose functionality programmatically, is that all these different types of apps want to be able to invoke this web API to achieve functionality. And very often they invoke it, and the invocation has to be on behalf of the user. We also have very traditional types of apps that are just running somewhere on some server that are autonomous, and they wake up at midnight and need to run reports or run some sort of functionality, and those also need to be supported by this new sort of ecosystem, and they want to call APIs to get their job done. So we need to be able to support all those different scenarios. Okay. Now, instead of having each one of your apps and each one of your APIs have to figure out how to do this from scratch every single time, a very common pattern is you abstract this functionality out into something called a security token server. This is also sometimes called an identity provider. Okay, so if you guys are ever using, well, in a sense, that's kind of like what Active Directory has been giving us for 20 years. But except we can't rely upon Kerberos anymore, right? Because we don't have domain join iPhones and things like that. So we need to up our game, as I said before, and abstract up the protocol stack or the technology stack, how we achieve our security. And so this is where these other types of security protocols come in. So the first thing we want to do is authenticate the user, okay? And so we have WS Federation, we have SAML 2. As I said before, those have been around for quite some time, but sort of the new kid on the block, and actually not so new anymore because it's been, OpenID Connect has been out for several years now, but really the kind of the modern version of these protocols is OpenID Connect. And the job of OpenID Connect is to allow these different applications where we have a user, right? So there are three styles. There are the server-side web app, the JavaScript app, and the native app. All three of these have a user, and that user needs to be delivered over to the security token server, and that's where they log in. The job of the security token service is to centralize logins and user management and provisioning and password reset and multi-factor and all of that, right? That's why we factor that out. So we need some way to have our apps send the user over there and have them do their login and then get the results back, okay? And that's these three security protocols, WSFed, SAML, and OpenID Connect. That's for the authentication piece. The other thing that we want to do then, like I said, is be able to invoke these web APIs. And so there's actually another protocol for that, and that's called OAuth 2.0. So I'll just say OAuth. OAuth is basically a protocol that's designed for doing API security. Okay, so these are strictly, they're very much related, but they are achieving two different things. So we have these set of protocols up here that are allowing a user to authenticate to the app, and then the app wants to call a backend API, right? That's why we have two different security protocols for that. Okay? Just mechanically, there are two different things involved. So I mentioned SAML and WS Federation, and so why wouldn't we keep using those? Well, it turns out that they're definitely the older protocols. And there's an analyst named Craig Burton. I think he's kind of famous. He spoke at the Cloud Identity Summit back in 2012, and basically made the proclamation that SAML is the Windows XP of identity. And it's obviously kind of tongue-in-cheek, but the idea here is that they're not the future, right? So nobody's putting more investment into SAML or WS Federation, right? They're antiquated, they're older protocols for an older generation, if you will. It doesn't mean they're bad, it doesn't mean they're not useful. They're also kind of like, they're not gonna go away, but it's not where the future is, okay? So that's why we don't typically choose SAML or WS Federation if we have a choice as our first choice for authentication protocols, okay? Also, there's this thing called OAuth, and I'm sure you guys have all heard of this before. And so very frequently people say, well, why can't I log in with OAuth, right? That's what Facebook does, OAuth style logins, okay? And so the problem with this is that, as I had already mentioned, OAuth is about API security. It's, strictly speaking, is not designed for authentication to that front end app. But people were using it this way. And so people were using it incorrectly for a long time. And this got to be so bad that the actual OAuth working group put together a white paper and basically said, hey, user authentication with OAuth 2. Guess what? OAuth 2 is not for authentication. They had to put together this article to try to publicize the fact that, look, everyone, you're doing it wrong, okay? So if you ever talk to anybody about OAuth, OAuth is not about authentication, okay? OAuth is about this delegated authorization so that apps can call APIs, and that's really pedantic, but the short of it is OAuth is how you can get to the API. OpenID Connect is the protocol for how you get to the front end for authentication. It turns out that actually what happened is OAuth has almost everything you need to be an authentication protocol, but it is missing a few things. And it was very popular, and it was being misused. So the old OpenID working group came forward and said, hey, our authentication protocol, OpenID, isn't really taking off, and it kind of has fizzled out. So they reinvented themselves and came up with a new protocol called OpenID Connect. So those are two different things. OpenID is the way old protocol. OpenID Connect is the modern one. And what they said is, let's take OAuth as a basis. We know it's very popular, and let's add what we need to that protocol to turn it into an authentication protocol. So what they, in essence, did was extend OAuth to give it enough security characteristics to really make it a proper authentication protocol. So that's why very often, if you're doing authentication and web API access, if you're doing OpenID Connect and OAuth, you're really kind of doing two protocols, but they're so similar, you're doing them one exchange that's achieving both ends at the same time, if that makes sense. So there are several specifications involved with OpenID Connect. There's the core specification and a few other ancillary specifications that most people implement. And then, as it says down here, the underpinnings are based on OAuth, and they're also based on this other type of thing called a JSON Web Token, because that's what we're going to be handing around to prove authentication, are these things called tokens. So one of the things about OpenID Connect that everybody was thrilled about is that it was designed to be very consumer friendly. And what I mean by that is the apps that are consuming it, very little complexity compared to the implementers. So the ones implementing the server, yeah, they have the hard job, but there are so few of those compared to the actual consumers. So it was designed to be very easy to consume and highly interoperable. It's all just HTTP based. HTTP and JSON based. So that means that when this spec came out, there were immediately lots of implementations for lots of different technology stacks. So that was a really good thing about adoption and interoperability. That's actually one of the complaints about SAML and WS Federation, is that those also were kind of hard to interop with, because very often in the Microsoft space, we very often use WS Federation, and the Java sort of enterprise ecosystems typically use SAML. And you always had a hard time getting those two to talk to each other. So OpenID Connect is kind of normalizing that, which is kind of nice. One of the other things about OpenID Connect is there's a certification process. So if you're going to provide an implementation, you can go to the spec committee, and they have these automated tests that you can run on your implementation to prove that it actually implements the spec according to the way it was intended, and that you are interoperable, which is quite nice. So the one I work on is something called IdentityServer, and we went through the process of getting this, certified. Actually, this is an older screenshot. We have a newer implementation called IdentityServer 4. But anyway, I've been through this process. I know what's involved with this. And this list, by the way, is growing and growing and growing. Right? There are many more up on this list than when I took the screenshot a while ago. But if you're going to be using OpenID Connect, you should absolutely go and get a certified implementation. And that just gives you a higher level of assurance of interoperability. And then if in the future you want to swap one out and with another implementation, because of the interoperability requirements, you will have minimal effort in swapping out different implementations. Okay. So as I mentioned, the one that I work on is something called IdentityServer. IdentityServer is the current version is IdentityServer 4. It is ASP.NET Core based. That means it can run on Linux, it can run on Windows, it can run on cloud, on-prem, wherever. It is open source, Apache 2 license. It is certified, as I had mentioned, and we're also part of the .NET Foundation, which is Microsoft's endeavor to promote open source in the .NET ecosystem. And so it turns out IdentityServer is being used by EUM under the covers to provide protocol support for their identity management offering. So what we're going to talk about next is basically looking at the details now of these protocols. And so again, the couple things that we're going to do is, first, we want to authenticate users, right? That's the first step, is the front-end applications, whether you're using a server-side web app, a JavaScript browser-based SPA-style app, or a native app that's running on your desktop or your mobile device, those want to authenticate the user, right? That's the number one thing we want to do. And that's the nice thing about OpenID Connect as a modern protocol, is that it it was designed to accommodate these different style of applications. Again, the older protocols like SAML and WS Federation, they were targeting more browser-based server-side web applications, and that's prior to when spas and mobile apps even existed and were popular. So that's the first thing we're going to do is authenticate our users. Then the next thing we're going to figure out how to do is have these apps invoke these web APIs. So that means we're going to need a token that the apps can pass to the web API so that the web API knows who the calling app and calling users are. Okay. So when you are using OpenID Connect, you're going to have a server. That's that security token server that centralizes your authentication. And for your applications to talk to this token server, that token server exposes some endpoints. And it actually exposes many, many endpoints. But the two main ones to be familiar with are something called the Authorize endpoint or the Authorization endpoint and the token endpoint. The Authorization endpoint is the endpoint that your application sends the user to in a browser to do authentication. Okay? So again, our apps want to know who the user is, so we're going to redirect them in the browser over to the token server, and that's to the authorization endpoint. At the authorization endpoint is where the token server will prompt for credentials, right? And it will log the user in whatever technique it supports. And then that authorization endpoint will redirect the user back to your application. Okay, so the authorized endpoint is basically where the browser is going to be visiting. The token endpoint is a programmatic endpoint. So once your app gets some results back from the authorization result, depending on the type of app you're building, your app may need to programmatically connect back to the token server. And that's what the token endpoint is for. So the token endpoint is purely programmatic. You make HTTP calls to it, and you'll get back JSON coming back from that token endpoint with whatever it is you're looking to get back, namely, well, tokens, right? Since that's the name. So the next thing we need to talk about is how your app is going to interact with this token server. And I mentioned roughly these couple different endpoints, but there are more details to it than that. And the details are broken up into what are called flows. And this term originally came from the OAuth spec. And then when the OpenID Connect spec came and extended OAuth, they beefed it up a little bit more for the authentication piece. So we're going to talk actually about, I think, 4 different flows during this session. There's the 3 at the top here: implicit flow, hybrid flow, and code flow. These are the flows that your interactive applications will be using. And so what I mean by the interactive apps, those are the server-side web apps, the JavaScript-based SPA apps, and the native mobile apps. These are the ones where a user is interacting with the app. And again, the reason we have different flows is because given the nature of the different apps, the mechanics of redirecting the user to the token server and getting results back are going to be a little bit different depending on what style of app, if you're server-side or client-side and things like that. Okay, but depending on your requirements and what you're looking to do, it's going to be one of these 3 flows. Okay, and you may start with one today, and then depending on as your requirements evolve, you might switch over and use one of the other 2. Okay. The other flow we're going to talk about is actually the simplest, and that's called client credentials flow. The client credentials flow is for when you have an app without a user, right? That's that scenario where I said you may have a server that wakes up at midnight and needs to call APIs. Well, to call the API, you're going to need a token, so that application will have to go and obtain a token, but there's no user, so you're obtaining a token on behalf of the app. And that's what the client credentials flow is for. So we'll talk about that once we get into our API section. So the first thing we're going to talk about is the server-side web application, okay, where we want to authenticate the user, and that's it. So all the server-side app wants to do is authenticate the user, know who that user is, and then maybe the app just connects directly to a database and updates data. And it does not need to invoke any web APIs. Okay, so this is the simplest scenario where we have a user. And so in OpenID Connect, we use what's called the implicit flow to do just authentication and nothing more. Okay, so the way this works is that your user is in your server-side web application, and that server-side web application is rendering, HTML into a browser, and the user is looking at that. And at this point, the user is anonymous. And so at some point, your application decides, okay, I need to know who this user is. So this is where normally your app would redirect to the login page. Except the whole design here is that we're not having the app do its own authentication. We're trusting the centralized identity system. So it'll redirect the user over to that centralized identity system. And again, that redirect endpoint is the Authorize endpoint that I mentioned before. That's the interactive endpoint that we send the user in the browser. So we will send the user in the browser, redirect them over to the Authorize endpoint in the token server. And as part of the OpenID Connect protocol, there are several parameters that need to be sent to that Authorize endpoint so that the token server can, understand the context of the request and understand how to satisfy this. So one of the parameters is something called the client ID. This is basically the identifier of the client application. The terminology in these protocols is that the client is the application that the user is using. The client is not the user is the user. So you'll often see this term client, and you just have to understand that that means it's actually the software, that's the application that the user is using. The redirect URI then is asking for or indicating to the token server that when the authentication process is complete, where in the application we would like the results to be delivered, okay? Because we need results from that token server. The response type parameter indicates what type of tokens you want back from the token server. And what we're asking for here with this ID token parameter is something called an identity token. The identity token is going to be a representation of the identity of the user. And that's how your app will know who that user is that there's going to be this data structure that's returned to your application that your application can validate and verify who that user is. The response mode is a parameter that indicates where you would, well, not quite where, but how you would like the results to be sent. So this is the URL that we want the results sent to, but since this is running server side, I would like them posted to the server. So that'll actually trigger an HTTP post to send that the token, if you will, to the server. The nonce parameter is a security feature in the protocol to prevent replay of the token. The token is meant to be used once to represent the authentication event, and then once your app receives it, it should never be reused beyond that. So a nonce is a number that's only used once. It's in the security protocol to prevent replay attacks. And the last parameter here is called scope. Scope is an indicator indicating that your app wants access to certain identity data about the user. Okay, so this is a white space delimited list of values. And this first value is basically an indicator that says, I want the unique ID of the user. Okay, these scopes basically map to claims or attributes about the user. So the OpenID scope is an indicator that, yes, you're doing OpenID Connect, and I need the user's unique ID. We call that unique ID the subject identifier because it is the identifier for the, the human, the subject that is making the request. And that's actually the most important thing in this entire authentication protocol, is that you want the user's unique ID, and the token server will return to you the same unique ID for that same user every single time they authenticate. Think of it as like your correlation identifier for that human over many, visits, if you will, to your app. Your name can change, your email can change. So those are all really awful identifiers, to be honest. So this unique ID is usually something like a GUID, right? A unique identifier that is never reassigned to any other user, random, that kind of thing. But it will be always the same value for that same user. And then there you can pass other parameters here indicating you want other things, right? Profile, email, address, phone number, and you can even come up with your own scopes that mean certain things to your organization. So maybe you want the user's employee information, and that means you want their employee ID and their employee phone number and their office location, and who knows what, right? It's totally up to you, and you can customize this. So the user gets sent to this authorized endpoint, and now the token server has all these parameters to understand the context of the request. Okay, what happens next? Well, since the user is not authenticated, right, if this is the very first time, they're going to be prompted to log in. And that's kind of the beauty of this, is that the outsourcing of authentication to the token server, the user then can authenticate with that token server using whatever authentication mechanism that the user has established with that token server. So very commonly, a username and password is something you might use, but the token server itself may support logging in with, social logins, for example, or the token server may support integrating with corporate login systems like Azure Active Directory, or if you're using like ADFS or Ping Federate or other types of enterprise systems. So that's kind of the beauty here, is that at least with IdentityServer, the implementation that I work on, it's entirely flexible, and that's actually quite the appeal of IdentityServer. It's very flexible in what you wire up to. So the user goes through an authentication process, whatever that is, and that's abstracted from the app, and the app doesn't have to worry about that, which is, again, nice aspect of this design. Once the user is authenticated, then the next step is an optional step, and that's the concept of consent. Consent is basically where the user is prompted and says, hey, the user has an account with the token server. The token server has identity information about that user, and this information is about to be released to that client application, the one that the user was using. And so if you've ever used Facebook or Google or any of those social providers to log in to any other app on the web, you're probably familiar with this concept, right? Because there's a third-party relationship between the app and your social login, the social login provider says, hey, you know what, I'm going to ask you if it's okay, because the responsibility is to the user to let them know this information will be released, okay? So if your application is third party to the token server, then consent is a very typical step. And this is very much covered in the OpenID Connect protocol flow. If the application, on the other hand, is actually a commercial login, like an enterprise style application, then consent is optional, okay? And so, the enterprise already has your account. Oh, I think we have a little bit of noise on the line. Actually, Dinesh, maybe you could. Okay. Sorry about that. So, so the consent for first-party style applications is optional, right? If it's a first-party application and it's the token server is owned by that same company, then they already have access to all this data, so there's no use in asking the user for consent. Okay. All right. So once the authentication is done, once the consent is done, then we can deliver the results back to the application. And so what happens is the token server will create a token. This is that ID token that I had mentioned, and it is delivered back to the application. And an interesting thing about the way it's delivered back to the application is that it's actually rendered as HTML into the browser. So the token server actually renders this form into the browser, and the form, the action of the form is back to the redirect URI of the application. Okay? So the interesting thing is that there's no back channel call between the token server and the consuming application. It's all delivered via the front channel in the user's browser. It's kind of an interesting aspect. It might feel a little hacky, and it is the web, so it's kind of duct taped anyway. But there's precedent here, because this is actually how SAML 2P and WS Federation also delivered their tokens back to applications. So they just pretty much followed in that pattern to deliver the token back to the app. Okay, so that token that we're getting back is something called an identity token or an ID token. And this is what's called a JSON Web Token. A JSON Web Token is a couple of data structures that are base64 URL encoded, and then there's a digital signature on top of that payload, if you will. And so what this has is, there's this header section that kind of gives metadata about the token, that this is in fact a JSON Web Token. The signature algorithm that we're using to sign the token is an RSA signature using a SHA-256 digest. And the key that was used to do the signature, the identifier of the key, is MJ399J something or other. So this is identifying information, metadata about the token itself. The payload in the token then has some claims that are protocol-related claims. So when the consuming application receives this, you have to unpack this thing, you have to do the digital signature validation, and then you do validation on the fact that the issuer of the token was the identifier of the token server you trust, that the expiration of the token is not in the past, that the audience of the token, meaning the recipient, is your application, right? You don't want to process tokens that were meant for other applications. And then here's that nonce that I talked about, that is for the replay detection. So you keep track of the nonces that you had previously requested and then are expecting a result for. So there's a bit of protocol validation here, but again, I said earlier that consuming this protocol, other than the digital signature check, right, the rest of all of this protocol validation is just simple stuff that you could even do from any programming language. So it's very, very easy to consume. For the digital signature check, I will say that that's where you typically need to include a library of some sort. But again, pretty much every platform, including JavaScript running in the browser, has the ability to do RSA signature checking. Okay, so it's all very, very consumer friendly, if you will. So once your app goes through the process of validating this identity token, once you've received it, then and all the checks pass, then the rest of the payload is information about the user that is now trustworthy. So now we know the user's unique ID, their subject identifier, is 182JMM199. That's the unique ID for Alice. And every time Alice logs in, that's going to be the exact identifier we get. Okay. As of now, Alice's email is this, and yes, it was verified. And if you had asked for other information, like maybe Alice's profile, you might get first name, last name, Alice's website address, things like that. It's entirely up to you what you put into this payload. But this is the most important thing in here from the authentication perspective, because that's the unique ID. Okay. There are a couple other things here that are information about the user. It's kind of like metadata. AMR stands for the Authentication Method Reference. It's letting your app know how the user authenticated. Did they use a password? Did they use multi-factor authentication? Did they use social logins? Whatever. So this is an identifier for your app to know what they did to authenticate. This might be important for authorization decisions, depending on what the user does in your app. And then the auth time is when the user authenticated. And again, both of these times are Unix times, basically. So you might say, oh, the user authenticated 6 hours ago. You might want to send them back to re-authenticate and refresh their login, if you will. Okay. So anyway, this is the result of the implicit flows OpenID Connect request. You get back this identity token, and once you've gone through all this validation, like I said, and you've looked at all these claims, you have authenticated the user, and we now know who that user is. Okay, that's authentication. So moving on then, we now want to use APIs. And so when we are accessing APIs, this is done in a couple different ways. One way to use an API is to access an API on behalf of the app. That's where I said that's like that server waking up at midnight calling APIs. There's no user. That's one way to invoke an API. You're invoking the API on behalf of the app itself, not on behalf of the user. Or we can invoke the API on behalf of the user. So that means the user has to be using some app, and that app then, when it, after it authenticates the user, calls APIs, and the API now will also know who that user is sitting in front of the application. So we have these last few scenarios to work through. I guess we have about 20 minutes left, so I'll do my best to fit this in. So the first scenario and by the way, this is now where we're moving into the OAuth part of the protocol, right? Previously, we were doing, once we got back this identity token, that was the OpenID Connect part, OpenID Connect. So the result of OpenID Connect is an identity token, okay? To call these APIs, we're going to be using what's called an access token. And if you go and obtain an access token, then strictly speaking, what you're doing is the other protocol, which is called OAuth 2.0. Okay? So depending on what you want back from the token server, an ID token or an access token, that really is sort of which of the two protocols you're doing, and you could be doing both, both of them at the same time, because you want authentication of the user and access to an API on behalf of that user. Okay, so the first scenario is the client credentials flow. This is where we have an app that wants to invoke the API on behalf of the app, no, not on behalf of a human. So again, what's going to happen is your application, before it can call the API, it must first go and connect to the token server, and it will connect to the token endpoint. And it will make an HTTP request. It'll be a post. It'll be to the token endpoint, and you will pass parameters, or your app will pass parameters requesting a token. You are using the client credential flow, so that means that you are going to be providing a client ID and a client secret, and the token we get back will be on behalf of your app itself. And then the scope parameter is used to indicate which API we want access to. Again, you can put in multiple scopes here because you want one access token that's good for both API 1 and API 2, but maybe not API 3, for example. If your client credentials check out, then the token server will return to you a token, and that token is what we then, send to the web API, and that token is what we call an access token. You typically send the access token to the API in the authorization header. You use the scheme of bearer, and then you put in the token. And the token is just a string. From the client's perspective, you just get the string, it's opaque, and you just send it along. You just pass it along to the API. And it's up to the API to validate this token. Okay? So the beauty of this architecture is that you can get one token that is good at multiple APIs, and your application only has one set of credentials. It's not with each different API, right? Very typically, people have like API keys. And that means you have 2 or 3 different APIs you want to call. You might have to manage 2 or 3 different API keys. And if that grows over time, then the explosion of credentials becomes hard to manage. So this architecture of allowing the token server to issue tokens, it gives you a level of indirection, and that really is helping kind of clean up the design here. So you obtain that token, you only have one set of credentials in your app, and that token can be used in multiple locations. And then those APIs, they don't have to worry about managing credentials, they just need to validate those tokens coming in. Okay? They validate the tokens because they fundamentally trust the token server. Okay? This token very commonly could be a JSON web token, which is the same type of token that we saw earlier for the identity token. Okay, so now moving along, the other types of scenarios we need to cover then are an app calling the API on behalf of the user. Okay, so again, here we're just invoking the API on behalf of the app, and the API doesn't know if there's a user, or maybe it doesn't even care. Okay, but if we do want to invoke APIs, and those APIs do care about the user, then when the application authenticates the user with OpenID Connect, we can also incorporate OAuth and request an access token. So the result of the interaction will still be an identity token, but also now an access token. So the 3 different app scenarios we have to talk about are the 3 different styles: the server-side web applications, the JavaScript applications running in the browser, and the mobile or native applications. So the first one I'm going to talk about are server-side web applications. So because the requirements now are a little different for a server-side web application that wants to authenticate the user and call an API, we're going to change the flow that we use. So there are a couple different flows we could use for the scenario, but hybrid flow is a very common one. So the hybrid flow is a protocol flow where we're going to be involving both the authorize endpoint and the token endpoint. But again, the same result will come back, is that we're going to get an identity token and an access token. So the way that this flow works now is that the client application, again, as a server-side web application, it wants to authenticate the user, so it will redirect the user over to the authorized endpoint, the same as we did before when we were just doing the implicit flow. Pretty much most of the parameters are the same, except we are now changing a few things. One is that the response type, we've added something called code here. So the combination now of code and ID token is what makes this the hybrid flow. We're basically requesting, I want an ID token back, the same as we did before on the front channel, but I also want this thing called a code coming back. Now the code is not the access token. The code is just something that will ultimately get you to the access token, and I'll talk about those details in a second. The scope then still has some scopes that relate to the identity of the user, right? Those are the OpenID Connect scopes, and those are affecting the ID token claims. But we also want, for the access token piece, the thing that we're getting the code for, the access token, I want access to both API 1 and API 2, for example. So this parameter, unfortunately, is pretty overloaded in OpenID Connect because it mixes requesting two different types of things. So some of these relate to the OpenID Connect side and the ID token, and some of them relate to API access and the access token. Okay, so the token server goes through the normal process. You authenticate the user, you might do consent, then you need to produce the results. So the token server will still create the ID token the same as we did before. It also generates what's called an authorization code, and that's what's sent back to the server. Now, the authorization code, like I said, is not the access token. It's actually a level of indirection to get to the access token. The reason we don't just send the access token back here in the result is because the protocol is designed to minimize exposure of the access token. It's only the server-side web app. This will ultimately be calling, some API somewhere. So it's only the server-side code that should have the token. And so if we returned it in through the browser, then you would be leaking the token to locations that it shouldn't or doesn't need to be. Okay. So what we do is we don't send the access token directly. We send a level of indirection with it, which is the authorization code. Once the server gets this ID token and the code, it goes through the normal validation process of the ID token that I had already talked about. Then it takes the code and it uses it to exchange back to the token server for an access token. This is where the hybrid flow uses the back channel or the token endpoint in the token server. So it connects back to the token server on a back channel, it sends the code, and now your client application has a secret. It didn't have a secret before in implicit flow. Now it will have a secret, and that ensures that only this application, server side, can actually utilize the code. Okay? The results coming back then are JSON data structure that contain your access token. And now that you have the access token, you can call the API. Okay? So those are the basic mechanics for obtaining a access token for a server-side web application. And really, because we're doing both ID token for authentication and access token together, we're using both OpenID Connect and OAuth 2. Okay, so now we have the last two types of applications. And those last two types of applications are the JavaScript application running in the browser and the mobile applications running on a user's device or their desktop. These applications, because they run in a fundamentally different environment, a more hostile environment than a server-side web application, we're going to use a little bit different protocol flow. A couple things here. One is that I mentioned in the previous slide, this client secret is helping us guard the code so that the malicious, nobody can intercept the code and use it. A client secret will not work very well in a JavaScript SPA application or in a mobile application that I've installed onto my mobile phone, because somebody will reverse engineer the code and somehow get that secret. So those types of apps that are running on the user's devices or in their browser, those are called public clients because they can't keep a secret. So we have to use a different protocol flow. And what we're going to do is something like a secret, but it's going to be a highly dynamic secret. So the protocol flow that I'm getting at here is something that didn't quite exist exactly in the form that we use today when OAuth first came out. OAuth did have code flow as part of the original flows, but they realized that there were some weaknesses with it. So over the years, the OAuth working group has released more specifications to kind of beef up the protocol and protect against various attacks. So what we're going to use is a combination of what's called the code flow and something called PXE. PXE stands for Proof Key for Code Exchange. PXE will help us with a dynamic secret as opposed to a statically configured secret. So the idea is that this will help, like I said, deal with some certain types of attacks against these JavaScript and native applications. Also, the reason we're not doing hybrid flow from the JavaScript SPA application or the mobile app is that the ID token was coming back on the front channel from the token server. And it turns out that when it comes back on the front channel, your application has to do all the token validation and the cryptography checks and digital signature checks. And it turns out that while those are possible for native and JavaScript applications, it turns out it's lighter weight if you don't have to. So it turns out with code flow, when you're using OpenID Connect, that the token, instead of being sent back on the front channel, can come back on the back channel, meaning it comes back from the token endpoint. And by doing it that way, you're connecting over, HTTPS, and you're letting TLS actually do some of the, do validation that you're actually talking to the right server, the trusted server. So the token coming back on the back channel, actually, you don't have to go through the validation steps. So the reason I showed hybrid before and now CodeFlow here is CodeFlow is absolutely the recommended approach for your JavaScript and your native mobile apps, as long as you also use Pixie. So it's the combination of these two. For server-side web apps, you have a choice. You could do what I'm describing here, right, for server-side web apps, or you could use hybrid flow. So it was more just showing you a contrast that that's also possible. In the Microsoft ecosystem, if you're using ASP.NET, then it turns out that the plumbing that Microsoft provides for doing OpenID Connect for server-side apps, hybrid flow is one of the common, options that they support. So they don't support Pixie though in the ASP.NET plumbing. So anyway, that's why hybrid is typically the one we use for server-side web apps if you're doing Microsoft stack. Anyway, so let's get into here and talk about our JavaScript app. So for JavaScript applications, the way this works with CodeFlow is almost very similar to how we talked about earlier. So the idea is that you're running in your browser, the application is running in the browser as JavaScript, so there is no server side, and you are going to deliver the user to the token to the authorized endpoint to log the user in. Same idea. You pass a client ID, you pass your redirect URI. That redirect URI again will now just be an HTML page loaded from some server somewhere, and that's the code running on that will be processing the results. We only want a code back from the token server. We don't want an ID token. And what we'll do is we'll do the same scope that we did before. And then this last parameter is the parameter involved with the Pixie specification I mentioned. It's something called the code challenge. And think of this as when you're doing Pixie, your app dynamically generates a secret, and it's only used on this one exchange with the token server. That secret is sent to the token server hashed. So this is actually not the dynamic secret, it's a hash of the dynamic secret. And the token server is going to store that away and use it later when we connect back on the token endpoint and do validation for us. Okay. So anyway, very similar requests as before, just the protocol parameters are tweaked a little bit. The result coming back now to your application, again, is going to be the authorization code. It comes back as a GET request instead of a POST because we're running client-side in the browser. So your JavaScript running in the browser will basically read that code out of the query string. Okay? Then your JavaScript will connect back to the token endpoint and pass its client ID, the code, and then it will pass the code verifier, which is the dynamic secret that went along with that code challenge. And the token server then will use the code verifier and double check that it matches the hash of what you had sent previously on the front channel. Okay? If all of this checks out, then you'll get back both your ID token and your access token. The ID token is you'll still parse this for the claims, right? You'll get the name and the subject identifier, and that's so that you know who the user is in the JavaScript. And then you have the access token, and you can use that to call your APIs. Okay? So that's how a JavaScript application connects to a token server. This recommendation, by the way, to use CodeFlow and Pixie is a recent change, if you will, from guidance in the specification committee. It's really only in the last couple months where this has been the shift in thinking for these JavaScript browser-based applications. Okay, so anyway, that's sort of the you heard it here first, I guess. This is kind of the latest news for the approach for these JavaScript apps. Okay, the last one, which I think I can fit in here in my last few minutes, is for native applications. Again, this is apps running, mobile apps running on your mobile phone, or even desktop apps running on Windows or Mac OS. And I'll just sort of cut to the chase here. The approach that these apps are recommended to use to authenticate the user is they also are requested to open up a browser. So the funny thing about this is that you're running on a native app, pretty much every platform out there these days has the ability to pop open a browser. So that's the recommended approach from the specification committees on how these native apps communicate to the token server. And that's actually really good because you've already done all the work in your server-side login page to get the user logged in and do MFA and all that, and password reset. So why reinvent that in a native app? Okay, so this is the recommendation from the OAuth working group. It's actually covered in another specification called OAuth 2 for native applications, and they talk heavily about using the browser and the security characteristics that it affords. So it turns out very similar. You're going to send the browser to the authorized endpoint that we did before, the same scopes that we talked about before. You might want to get this thing called a refresh token. That's I don't have a ton of time to talk about that, but offline access is how you trigger requesting what's called a refresh token. Again, we're going to do code flow. We're going to do Pixie, so we talked about that already. The last thing that's sort of interesting here is the redirect URI. And the redirect URI, there are a couple different styles for using this, but one of them is this style here, which is a custom URI scheme. The idea here is that your native app launched the browser. The browser is going to get back the code, right, in the URL. How do we then get the code from the browser back into your native application? Okay? Well, it turns out that pretty much every platform, including mobile platforms, has the ability for you to register a URI scheme and associate it with a specific app, so that when your browser navigates or is redirected to this special URI prefix, the browser knows to launch this native app on the operating system, and it passes the URL of the current browser window into that application. And that's the trick for having native apps launch the browser and then receive the results. Everything else about the protocol flow is basically the same. You get the result back, it goes to the custom URI scheme, the browser launches the native app for that platform, passes that parameter, the query string parameter, and the app does the same thing that the SPA app did, which is exchanges the client ID, the code, and the code verifier, and you get back your access token, your ID token, and then you can also, like I said, optionally get back this thing called a refresh token. The refresh token is so that you can programmatically in the future go back and get new access tokens. And you can do that without re-prompting the user. So that's sort of like you can perpetually stay logged in a mobile app, if you will, by using refresh tokens. Okay, I know I covered a ton and I did it within the hour, so I'm actually surprised I was able to pull that off. Here are a few more resources if you're interested in learning more about these protocols or IdentityServer itself. The URL at the bottom is our GitHub repo with our code. So I thanks for giving me the opportunity to chat with everybody. I hope this was useful. I think we could probably, I don't know if Dinesh, we have any questions. But I know that we may have some questions, and I know that Dinesh has some closing comments.
Yeah, thank you very much, Brock. That was nicely delivered. I'm sure our viewers or listeners, in this case, we appreciate your time. Just upcoming events, we are working with a new partner called Valo Teamwork. They're publishing a solution to provision sites and such within SharePoint on premises or Office 365. So join us on February 21st, lunch hour again, Eastern Standard Time. You can register on our website for that, as well as we have another upcoming webinar about developing custom connectors on February 28th. And if you're heading down to the SharePoint Conference North America, please feel free to drop by, visit Logan or Peter Carson on May 21st to 23rd, 2019. We don't really have any additional questions that are unanswered at this time. We got some good remarks about the webinar. So I just want to say thank you again, Brock, and thank you again, everybody, for giving us your lunch hour. And you get back 2 minutes to finish up your lunch, I guess.
All right. Thank you so much.
Okay. Take care. Bye-bye.